Well, it's time for another tutorial, and in this tutorial we're going to cover the process of making a simple block mold, a simple cut block mold. And yes, we've done this before, but in this tutorial we're going to be using a new product that we have and just discussing a lot of the mold making basics that you got to understand to have good, successful, high quality molds. Now, one of the first and foremost things about using something like this tin cure formula, this 5092, is this particular approach. Those of you who are molding 3D printed patterns or other pattern surfaces that don't always cooperate with a platinum cure system, 5092 is a great alternative to that. It can still be inhibited, but it is much harder to inhibit a tin cure system than a platinum system. So that said, let's get started. Now to start, we need to introduce a new silicone. This is our new tin cure silicone, the GT5092. And this is available with two different catalysts, and we might actually be introducing a third. But for now, as the kit comes, these are sold separately depending on how you order this. But we have the lightning fast, extremely fast catalyst, and then we have the medium catalyst. So the slow catalyst, the way tin cure silicones work is they are cured by ambient humidity. So the drier the climate, that's going to tend to slow it down, whereas warm, humid climates speed it way up. So that's something you want to be aware of when you're using a tin cure system, that tin cures are cured by ambient humidity, hence the condensation cure. So that's an important detail here, because if you are using this system in a very dry climate, sometimes you might even want to mix the red and the yellow together to get a faster working time. But just be aware of that. If your silicone is curing way faster than it says on the data sheet, that's probably because you have high humidity in your working area. Now, the other additive that's real important is the Thixo for this. This makes this silicone a brushable consistency. We won't be using that for this video, but that's an important thing to remember. If you're making large brush-on molds or anything like that, this will drastically change the physical properties as far as for brush-on. So this will change it from what's called a Newtonian flow liquid that settles and seeks a level to a thixotropic liquid, which now is a material much like peanut butter. Think like a thick paste that when you spread it up on a vertical surface, it stays put. So for today's mold, we're going to be using just the medium catalyst. That's going to allow for about a 20-minute working time and about a 4-hour demold. So real important, though, to remember that, again, condensation cure means that it relies on ambient humidity to cure. So higher humidity is going to mean faster set times. Now, here's the other thing that's an important detail about this new silicone formula. This one is designed to have a really long library life. And that's an important detail when you're looking for tin cure formulas. Tin cure formulas are notorious for their shorter lifespan. And this particular formula is one of the few, even with the fast catalyst, that has a very good, very stable library life. And that's why this particular formula is really popular with art bronze foundries, people that need to archive molds for long periods of time and come back and still have usable, good molds. I actually have a mold that I made with this years ago, all the way back in fall of 2000, that I'll have to show this in a social media post or something. But I actually have an old mold made with this that I'm still able to pull copies from. I had forgotten about this mold and made it literally 23 years ago, almost 23 years ago. And it is incredibly stable. So that's a real important detail. Now, many of you that are new to some of the different silicone formulas, like platinum versus tin cure or condensation versus addition cure, some of you might be wondering why I would recommend this over, say, one of our platinum systems. And the main reason for using a tin cure system is this is almost impervious to cure inhibition. I say almost because there's always something out there that's going to throw some curveball at you. But these are excellent silicones to use for applications where you're molding a pattern where you may not have 100% control over what that pattern has been exposed to, and it might have come in contact with contaminants, and you don't want to risk it, and you don't want to spend the time running tests on it. Tin cure formulas like this are much more robust when it comes to encountering contaminants on a surface of a pattern. So enough of that, we'll get on to the actual mold now. Okay, for this mold video, we are going to be making a very simple block mold of this little hollow plastic chess piece. And I chose this particular pattern so we can explain a couple of different scenarios that some of you might encounter. Now, the first and foremost thing you want to be aware of, and this is something I see when people are starting out with mold making, one of the common mistakes they'll make is they'll take some kind of mixing cup or vessel like this that they can mount on a surface, and then they'll fill it up with silicone and they'll immerse their object in it. Or they'll put it sideways in a box and fill the first half of the box up with half of the mold material, let that set, spray release on it, and then fill up the other half. Now, the problem with either of those approaches of putting something down like this or putting something sideways like this is that almost guarantees that this half of the mold will be littered with air bubbles. And when you use this kind of approach, the same thing can happen. Even if you vacuum degassed your silicone, what happens is bubbles that are still making their way up to the top will find their way stuck along the way on the pattern. So any little outcropping area like this, and again, what you wind up with is a mold that is just peppered with all of these surfaces, have tons of little air bubbles on them. So almost like a sponge. So real important, always configure your part so it's mounted at the bottom of the mold container, and you've built your box and you've configured everything so that the air bubbles can rise away from the part. That is, I cannot stress that enough. That is one of those mistakes that I think we've all tried that at some point in our mold making career, but real important to remember that when you make a mold box, you always want to pour so the bubbles can naturally rise away from the pattern. Now, this presents a little bit of a tricky situation because we have these little ledges like this. So we're going to tip this over, and that's one of the things I wanted to cover in this video, is how we can rock this from side to side to help alleviate some of that air entrapment here. Now, the main thing you want to make sure you have handy is a hot glue gun is an excellent way to make sure we've got our pattern secured. But remember, there's a lot of different ways you could secure a pattern like this. You could use wood screws if you're working with a wood pattern. You could use super glue. But the most important consideration is remember that your pattern, especially if it's something like this lightweight hollow plastic, it will have a tendency to float. So if we put this over and we fill this up with our mold material, what's going to happen is the silicone is very dense, this hollow plastic is low density, so you have a natural tendency for that pattern to float up and pull away from that baseboard. So if you have not affixed this to the baseboard in such a way as to prevent it from floating or moving around, it will do just that in the mold making process. So real important to make sure you've got that secured. Now, the other thing is we've got a little bit of a gap down here from gluing that down, and that's where we're going to use some of our Protolina clay to fill in some of those areas. Now, this is already pretty tight down here, but just to be safe, we're going to roll out some clay and put it right in that gap just to make sure we don't have our silicone creeping underneath our part. Now, here's the one last little detail. This is a hollow cast part, so there is an air pocket in this, but as far as I can tell, there's no breaks in it, there's no openings. And that is also really important because if there's so much as a pinhole in this, the air trapped inside will want to move out and upward. So we could have a beautiful mold that has a big pocket of air inside it if that air is allowed to move around. So if you're concerned about that, drill a hole in the baseboard and give it a place for that pressure to alleviate. So be aware that if you've got a hollow pattern, be prepared for that air to move around. So if you don't have the air completely encased in something, if there's any way the air can move, it will move. So that's the main thing we need for our mold is a hot glue gun or some other way to fix our object to be molded to a baseboard. and we need some protolina clay. And again, this is sulfur-free clay. It's not as critical with this being a tin cure mold, but still, anytime you can eliminate potential for contaminants in your shop, that's always a good thing. Now again, we're just going to roll out just a very small little clay snake and push that into that gap. And I'm not going to go too crazy with this just for time's sake, but remember that the more time you spend prepping your pattern and getting everything nice and pretty, the better quality part you're going to be able to get out of your mold. Now, if you don't have a good set of sculpting tools, you can always take a popsicle stick like this and break it and then use that to create a little edge there that you can use to push that clay in. But again, ideally, this is one of those situations where you want to be using a good sculpting tool to push that at a right angle and get a nice clean edge there. Okay, now we're ready to fix our mold tube over the top. Now this is just one of our, actually one of our longer tubes that I've just cut down to make it fit. So I think I took a 12-inch tube here and chopped that down, but definitely check out our previous video about mold boxes and that sort of thing, because in that we go into a variety of different ways to create mold walls. And one of the simplest, of course, is foam core. Foam core board is fantastic for this. But hot glue is great because you get a nice clean seal on your mold box, and you could always use modeling clay to reinforce that seal, but this is a great way to create a silicone tight or watertight seal around your pattern. Okay, now we're ready to release our pattern. We're going to be using the Super Release PTR, formerly known as Eject It 33. And real important to remember that this is an ideal release for slick parts or parts that are non-porous. So if we're molding something that is made of bone or wood or plaster, anything that's porous on a microscopic scale needs to be sealed first. And be sure to check out some of our other videos. I'm going to put a link in the video description to our video library because we have a lot of resources there about basic molding and casting situations. So a lot of stuff there that you want to be aware of, and we have it much better compiled on our web page than we do out on the wild west of YouTube. So anytime we're dealing with a non-porous piece like this that's just plain plastic that's non-porous, we can easily release that with the Super Release PTR. But again, remember, if you're dealing with a porous part, it has to be sealed first. And it doesn't take much release to release our pattern in our mold box. We're just mainly, even though silicone doesn't really have any adhesive properties, this will make it demold that much better. So just be aware of that. Every now and then you could encounter a plastic or something that does have some component in it that attracts the silicone. So when in doubt, make sure you release your part and of course your mold box and your baseboard. And that's why we want to take that extra step to secure everything first before we spray our release. Because obviously, once we spray our release on everything, nothing's going to want to stick. For example, hot glue, super glue, things like that. So always secure everything before you start spraying release. Okay, quick word about calculating volume. If you have one of our molding and casting guides, this has an excellent section, if I do say so myself, in the back where we explain calculating volume. So if you have that, you can always refer to that. We also have a whole section of videos on poured block molds that go over volume calculation in greater detail than I'll cover here. But the main thing you need to know is the volume formulation for a cylinder. So volume for a cylinder is pi, or 3.14, times radius squared. So in that case, this would be 1.75. Radius squared times 1.75 times the height. So here for this mold box, since we have a 3.5-inch mold tube, we have 1.75 times 1.75 times 3.14 times 4 inches, which is about the height of our mold box. And that will give us our cubic inch volume. And that is the critical number here to calculate how much material we need. Because you'll notice if you check your hymnal here, most of our silicones, or typically all of our silicones, will have the specific gravity as well as the cubic inches per pound. And that's an important number in calculating how much material you need. This is, again, this is one of those areas where all the time we get phone calls where people have miscalculated how much material they need because they're eyeballing it. So the math doesn't lie. Make sure you do the right calculations and prepare for exactly how much silicone you need. And this is why I recommend to a lot of you who call in and order supplies, this is why I recommend that you make your mold box first, because yes, that's going to slow you down a little bit, but once you've built your mold box, you know exactly how much material it's going to take to fill that. So if you're just guessing, you could either order way too much material or not enough. Okay, so I've calculated my volume at right around, it's going to take right around 1.5 pounds, a pound, 1.6 pounds roughly. And if you convert that over to grams, that winds up being right around 725 grams. Now, just for the sake of this video, to keep this fairly simple, I'm going to do 700 grams of base rubber to 70 grams of catalyst, since this is a 10-to-1 mix ratio. Now, it's a good idea anytime you're handling really any kind of chemicals in their raw state to wear gloves, but especially tin cure silicones are not as nice and gentle as the addition cure formulas. So real important, wear gloves. Now the other thing is your mixing cup. When you're mixing this up, your bucket, your mixing vessel, whatever you want to call it, make sure that you've got enough space in this to vacuum degas. So I'm overcompensating here, so we have more than enough space. But remember that if you're mixing up silicone to fill something like this is going to take up a minuscule part of this bucket. But when we subject this to a vacuum, that's going to rise and then fall. And that's when we'll know we're ready to pull that out and pour it. But if we mix up a huge batch where we're right up here at the top, it's not going to have enough room to expand and collapse. So real important, make sure you plan ahead for that and you have a mixing cup that has enough room for that to expand and collapse. And again, this is also why it's a good idea to do everything in one bucket so you're not having to transfer it around and dirty up multiple mixing cups. And also with tin cure silicones, I mentioned this in our previous video showing the 5092, always a good idea to make sure you mark on your buckets once they've been used for tin cure that these are tin cure buckets, because that way you don't get any cross-contamination, because tin cure silicone, the catalyst especially, is like kryptonite for platinum silicone. So just make sure you keep everything separate so you don't have any cross-contamination. Okay, so that's at about 600 grams, so just a little bit more. This is where it takes a little bit of finesse to stop that pour and not wind up with way more than you need. So that's a little bit more than I need. I've got 720 grams. So that means, again, 10% of that means we'll use 72 grams of our catalyst. Now, these catalysts do settle, and they have a pigment in it to help you see when that has happened. So make sure you shake that up really good. You should have a really bright yellow catalyst when you're working with the medium catalyst. And your scale, most digital scales will have a tare button. And what that does is just resets your scale to 0 no matter what's in it. So you notice I already have my mixing stick in here. Everything's ready to go. So I just need to add my 72 grams of my medium catalyst. Now, one of the nice things about tin cure formulas is we can be off by a little bit. You don't want to push your luck on that, but tin cures are much more forgiving when it comes to the amount of catalyst. I've had customers that have sometimes erroneously put too much catalyst in or not enough, and typically what happens if you put too much in, it sets faster. Not enough, it typically cures slower. Now, if you're way off, then obviously then you're going to start having some cure issues. But it's one of those nice things, one of the nice side effects of tin cure and the way that catalyst works is you do have a little bit more margin for error. And remember, our working time starts as soon as we put that catalyst in. So you want to make sure you get everything mixed up really good and have one nice uniform color. And also a really good idea to just stir deliberately. Hand mixing is what I prefer for this because when you're working with a tin cure when you're working with a tin cure system, typically you have a really thick base rubber and a low viscosity catalyst. So really good idea to just take it slow and carefully work that in, because if you try to put a jiffy mixer down in there or something, you can easily just splash that catalyst right out. So take your time, get everything stirred up really good, make sure you have a nice even color, and that's a good indication that you have everything mixed up in accordance with the prophecy. And as always, make sure you're scraping the sides and the bottom of the mixing cup so you get everything incorporated really good. So again, one of those rookie mistakes is not scraping the bottom really well, and then you wind up when you need that silicone that's down on the bottom, when you do go to scrape that out, that winds up being very unmixed, nasty, gelatinous silicone and never really properly cures. So make sure you take the time to scrape the bottom really good, because when it counts, you need every gram of silicone out of this batch. You want to make sure that what's down at the bottom is properly mixed. We've got our silicone in our vacuum chamber. And what I want you to see here is how the silicone rises up and then it's going to collapse. And that's what we're watching for anytime we're degassing a material. We're watching for that rise and then the fall. If we don't have a big enough mixing cup, it can't go through that cycle. It's just going to spill out everywhere. So make sure you have enough room. You see how much that's expanding? We want to make sure that we have enough room for that to expand and then collapse. And you'll find that the more humid the work area, the more expansion you're going to get. So that's always something you want to be conscious of. And also, the more air that you work into the material in your mixing process, that's also going to contribute to that expansion rate. So that's real important. Don't whip air into it. Now see, it's kind of undulating like some kind of creature. That's fine. This is ready to pull out. All those little bubbles, once we turn off our vacuum, those are going to collapse. Okay, we've got our vacuum degassed silicone and we are ready to pour. So again, we want to just pick one spot and pour in that one area and let the silicone seek its level. And one thing, again, that I'm going to do here is I'm going to turn this at a slight angle. And what that's going to do is allow that silicone and the air in front of the silicone, more importantly, to move around and up. And that will prevent us from having a big air void trapped right there, because even if we vacuum degas something but we have it poorly configured, we still wind up with air entrapment. So that's important to remember. Vacuum degassing is great, but if you have a poorly configured model, you can still trap a lot of air. And this is where, again, we're going to go ahead and go in with our stir stick to scrape out all of that silicone. So if you've neglected your mixing duties or your stirring duties, this is where you're going to find out, because we want to get every bit of this out. Even tin cure silicone is too expensive to waste. Now, the little air bubbles you see on the top, those are going to break here in a minute. But the thing we want to look for right now is just make sure we have a good seal all the way around our mold box, or mold tube in this case. Make sure nothing's leaking. This is where having some water-based clay is really handy, because if we do have something leaking, water-based clay is a great way to seal that up without having to break out our hot glue gun all over again. And that will very easily just take a big chunk of water-based clay. We can smear that around the base if we do have any leaks. But again, can't stress enough, this is why it's really important to have everything secured on your baseboard, just in case it has to be moved around to alleviate some of those little air bubbles. So now we're going to let this sit and cure completely, and we'll be ready to demold our part. Okay, so it's been about 4 hours since we poured up this mold, and everything has cured nicely, so it is time to open up our mold. Now, quick word about opening up a mold like this. The shape that I've chosen, this simple pattern that I've got, this little chest piece, doesn't really have a front, back, or sides or anything like that. So this is one of the very few examples where you would not need to be conscious of where you're cutting your seam. But if you are worried about that, if it is something that faces a specific direction, you'll notice in a lot of our other block mold videos, I'll write instructions down around the baseboard about where the seam should be, or about critical areas, like say if something has a face over here or high detail on the sides, I want to make sure I avoid those spots when I'm cutting open my mold. So again, this is one of the few times where it's not really going to matter where we cut through the mold. Now, first things first, I just got to remove our tube around our block mold. There we have our piece, our hollow piece. You see the bottom just snapped right off of it here, but got a good release on it. And I'm just going to make my seam down one side. Now, to do this, going to use a scalpel, and a scalpel like this, these are ideal for cutting open molds, but remember, they are very, very sharp. Sharper than an X-Acto knife, believe it or not, so be very careful when you're using anything like this. And what I'm going to do is I'm going to make a little S-shaped cut, and I'm going to keep it fairly tight, because ultimately I want my silicone mold to key back together like this. And at this point, I'm not really trying to get to the piece yet. I'm just keying the outside of the mold so that this will all go back together. And now once I've got that key cut, I can come back in and now cut all the way down to the piece. And this is one of those processes that just takes patience to cut open a mold like this. Obviously, an extra set of hands is not a bad idea, but no matter how you do it, just take your time so that you don't make any cuts that you can't undo later on. So take your time opening your mold, and you will thank me for that advice later. And there we have our completed mold, and our original is intact. And if we are so inclined, we could go back and make another mold of that. And you'll see that that cut block mold just goes right back together like it was never cut at all. So if we're careful making that cut, we can have a really nice clean seam. And because this is round, it's very easy to secure this with electrical tape or rubber bands, anything to secure that equally around all the sides. So now here is our mold ready for casting. As is customary in our YouTube videos, Typically like to pour a quick cast just to show you the end results of our finished mold. So we've got that secured with some friction tape, otherwise known as electrical tape. And we are going to pour this up in our ever popular house brand resin. This is the ArtCast Pourable. Now, this particular resin formula is 1-to-1 mix ratio by weight. So real important there. That's one of the reasons why when you get your A and B, you'll see that your B is a little higher than your part A. That's all in accordance with the prophecy. The A is denser than the B, so hence the difference there. And so again, mixed 1-to-1 by weight. And that's one of the trade-offs. This is an inexpensive resin, but it's a really tough resin formula, and it gives you about a 3-minute working time. If you need a longer working time, we do have a 6-minute version of this resin formula. But again, being that this is a 1-to-1 by weight ratio, it's a good idea to use an accurate gram scale. Now I'm going to mix up more resin than I actually need for this, because I've got some other little molds that I'm going to pour up with the leftover resin. And again, anytime you're pouring up products like this, especially if the components look similar, this one doesn't, but a lot of our products, there's some A and B components that look almost identical. So anytime I'm measuring those out, once I've dispensed one of the components, I set that aside. And that way I don't accidentally grab that part twice. Now, just like with the silicone, remember that the components are stupid. They don't know your intent. So as soon as the two components are in the mixing cup together, that is when your working time starts. So it doesn't start when you start mixing, it starts when those two things go together. And also doesn't start when you start pouring. It's as soon as those materials go together in the mixing cup, that is when your timer starts ticking. So be aware of that, be ready to get that mixed up thoroughly and poured. I probably stirred a little bit longer than I had to, but what we're going to do on this, because we do have that little lip there, we're going to pour it in and then pour it back out at a slight angle. And that way I can make sure, and you couldn't see it on video probably, but I got a little air bubble that burped up to the top. So that's a good indicator that we burped that resin and gotten any air bubbles out. Now, I always like to pour up a part like this, a really thin cross-section part, and I can use that as a gauge to see what's happening here, because this will cure from the thickest point and radiate out. So this will cure last. This part's going to cure first. This one is going to cure after that. Okay, our resin has cured completely. You can see Mothman's little toes and wingtips have turned solid, but the real indicator is these really thin areas right up here, these drips. When you can peel those off, then you know you're ready to demold your resin cast. Now, your first cast that you get out of a mold like this is always a learning process for your mold. So remember that first cast is going to tell you a lot about what you need to do with subsequent casts. So little problem areas, any areas that have trapped air bubbles, anything like that, this first cast is your learning cast. And also, this is a good way to clean out the mold. A lot of times when you're working with a mold like this, your first cast, if you molded a clay original, you might have some little bits of clay and things like that in here. So I always use this first cast to learn the mold and, more importantly, clean out the mold. And there we have a perfect cast. We don't have any little air entrapment around that ridge, and we have a very nice clean part. The only cleanup is just we can take this to a piece of sandpaper and sand off that little meniscus there, and we are ready to go. So now let's check on Mothman. Ah, and behold, there's our little Mothman ready for paint. And again, just very minor cleanup. And that's one of the nice things about this particular resin. This is very easy to paint, provided everything has been mixed in accordance with the prophecy. You can easily prime this with either the Sculpt Nouveau primer or the just Rust-Oleum Auto Body primer. So there you have the process of making a simple cut block mold using 10 Cure silicone, our new 5092 formula, and of course a simple resin cast using our ArcCast pourable resin. So those of you new to the block mold process, or if you've been just wanting to brush up on some other block mold techniques and just make sure you understand that process completely, both for cut block molds, one-piece block molds, two-piece block molds, that sort of thing, be sure to check the video description. I'm going to put a link to our video library to the poured block mold section in there, so be sure to check that out. And of course, I'll also have some links to the resin casting page as well. So all of that, again, can be found in the video description, as well as all of the products we use. So remember, all of the products we use in our tutorials are available on our web store. So again, be sure to check those links out. And if you haven't already, this is the call to action point of the video, where if you haven't already, if you just discovered our videos, please make sure to like and subscribe if you haven't already. And thanks again for watching.